All right, today I'm going to show you an example of one of the problems that I've assigned for today. So you'll start by going to physicsclassroom.com, then going down to Concept Builders, and then you can go down here to Waves and Sound, and we're going to go to Rocking the Boat. So we are going to look at several different situations where you have a boat bobbing up and down and try to find the wavelength, frequency, period, amplitude, and speed of the water waves. So we clicked on Launch Concept Builder. When you get here, you can either make this larger by clicking and holding this button, or if you want to make it the entire screen, then you go over here and click this button. All right, make sure you put your name here, not Mrs. Sutherland. I'm doing that because that's my name. And I'll go ahead and just do a master level question. If you need help with wizard level questions, you can reach me during office hours. All right, so let's read this question. Two boats are anchored in the harbor, separated by a horizontal distance of 30 meters. That means the left to right distance. The boats bob up and down as waves enter the harbor. When one boat is at its highest point, the other boat is at its lowest point, and there is one wave crest between them. So let's stop there and see if we can figure out where to put these boats. If I click through here, I can put these boats at any place. So it says one boat is at its highest and the other is at its lowest, so this seems like it could be right, but there needs to be one wave crest between them. So if I click here, they're both at their highest point. I need this one to be at its lowest point and one crest between them, so I believe this is the correct diagram. All right. So now let's move on to the rest of this business. It said that the boats are 30 meters apart from the horizontal distance. Well, let's see. That means we have going down, going up, and back down. That's 3 parts. 1, 2, 3 parts. So I could equally say there's 1, 2, 3 equal parts, and it's 30 meters. So that means it would have to be 10, 20, 30 meters. Well, one wavelength is from crest to crest or from trough to trough. So from crest to the next crest has to be 20 meters. I'm going to put 0.0 because it says here at least 2 significant digits. Now, we also could have done that by saying 30 meters divided by 3 times 2. So it's 2/3 of this 30 meters. All right, so we have the wavelength. Each boat makes exactly 3 complete up-down cycles every 18 seconds. Well, that's telling us information about the frequency because frequency is cycles per second. So that means if I have 3 cycles every 18 seconds, I would need to have 3 divided by 18, which gives me 0.166666. So that's 0.167, I think. Or maybe I'll do, it's kind of weird the way they do it. I'll just do 0.166. So that would be the frequency. Now, the period is actually the opposite of the frequency. So the period is how many seconds per cycle. So that would be 18 divided by 3 in this case, which would be 6, but I have to have 2 significant digits, so I have to put 6.0. Now the amplitude is going to be from the top of the wave to the center or the bottom of the wave to the center. But it tells me that the vertical distance is 3.8 from top to bottom. So that means I need to take 3.8 divided by 2 to get my amplitude of 1.9. All right. Now, speed, you can either do wavelength times frequency or wavelength divided by period. Now, since I had to round my frequency, I think it would be better if I did wavelength divided by period. So I'm going to do 20 divided by 6, which is 3.33. And let's see if I try it the other way and I do 20 times 0.166, I get 3.32, which I think is a little bit more rounded. So let's see if they accept these answers. All right, I got it. So I hope that helped you. If you still have any more questions, please feel free to email me or see me during my office hours, which are posted on Google Classroom. Thanks. Have a great day.